Hello everyone and welcome. Today we're going to be doing a quick introduction and tutorial of Matchstick. And Matchstick is a unit testing framework for the graph protocol. What that basically means is that using Matchstick, you can test out your subgraph and specifically your mapping functions to ensure that they will run successfully before you deploy. Because as you know, right now, if you would want to try something out or if you want to just test out a bug fix or anything, you would need to deploy your subgraph, wait for it to sync, then check the logs, which obviously isn't that great, especially if your subgraph is really big, because sometimes it can take up to a few days to fully sync after it's been deployed. And even with like the case of Uniswap version 2 subgraphs, it can take a bit more than a month to fully sync, which is obviously a insanely long time to just check the logs and see if things are working as you expect them to work. That doesn't mean that the Uniswap version 2 subgraph is bad. It just means that it's a really big subgraph. It uses a lot of data. And yeah, that's why it syncs for so long. But using Matchstick, you can write unit tests to ensure that that logic is working and is all right before you deploy the subgraph. Now, how would you do that? So over here in our GitHub repository, if I scroll down to the installation bit over here, I'm on a Mac, so this is what I'll be using. And say I've prepared a really simple demo subgraph, just to showcase Matchstick. By the way, the full demo subgraph is also on GitHub. I will post a link below in the description, but the demo subgraph basically acts as a showcase for everything that is functionally possible in Matchstick, showing users how it can be used. So in the demo subgraph, we've got a really basic data source. The data source is called my data source. It has one entity. It has over here has one entity. It has one event handler and one API. All of that is local, so this address isn't a real address. But basically, what the most important bit is the mapping functions anyway. And let me just quickly remove what I'm gonna show you. So over here, we have a handle new entity, which basically accepts a event, and it creates a new entity with the ID from the event, and then just adds the name field to be equal to the name in the event. And at the end, it just saves the entity to the store. So this is really a very basic event handler function, but most event handlers and most mapping functions actually look like this. So you would just create an entity, you would do all sorts of logic, so all sorts of logic here, and then you would save that entity to the store. So now, how would I try this out if this handler works the way I want it to work? Well, I will just go ahead and create a tests directory. So in the tests folder, I will create a example test.ts file. And here we're going to write our unit tests. Now, what we're going to need here also is a npm dependency that is a helper dependency. That's basically wiring up Matchstick to our mapping functions. So this dependency is called Matchstick AS, and I believe I already have it installed, but over here, yeah, I have it installed, but it's just a case of yarn add Matchstick AS. That should do the trick for you as well. I'm going to stop it because I have it installed, but we will need this dependency in order to use the helper functions and define our unit test blocks. So over here, I'm just going to import from, because I need to find it. So we're importing from Matchstick AS assembly index. This is basically what I think this is what, yeah, this is what we need. And we're going to import the test function from here. So now what we need to do is export a function named run tests. And for the time being, it's important to have the function exactly named like this, because the matchstick binary is going to go in our mapping functions and look for a function named run tests. And in the future, this can be made a bit easier, but for now, just rule of thumb, call this function run tests. And inside, we can start defining our test blocks. So we do test, then we do simple test, which is the name of the test, and then we do a function, which is our test function. Now, let me just paste a bunch of code because I don't want to write it by from scratch, but I'm gonna explain it. So, and I'm just gonna show you what I'm looking at. This is a blog post, which I'm gonna link below in the video, but this is basically everything that we are talking about in this video can be found on this blog post. So over here, as I said, we have a entity that just has an ID and a name in our data source. We have this is the event, this entity, this is the event that accepts an ID and a name. And this is our mapping function. Now, in terms of the tests, we will just copy and paste this test, and I will show you what it does. So simple test. Then we need to import a few things. We need to import the event. I'm going to create this like this. We need to import Ethereum from GraphTS, and we need to import the handler from our mapping file. We also need a bit more imports from Matchstick.as, like the Assert class, and we need the clear store method, which is not required, but it's nice if you clear your store at the end of the test block, just so that you can start off the next block with a empty store. So the first one, generalize, we're going to do. The first thing that we can do, that we need to do here is instantiate our event. Now we are just creating a new custom entity, which is an event. We're creating a new event. We're setting its parameters to an empty array. And we are creating here two event parameters, one for the ID and one for the name. The ID param is just some random ID. The name parameter is Don Draper. So this entity is going to have a name of Don Draper. And then we are pushing these two event parameters to the event. And here is actually the most important bit, how to call the mappings. So we just call the handler directly, passing in our newly created event mock object as an argument. That's going to run all of our handler logic on the event. But then we also need a way to actually test if the handler worked as expected. And here the assert class actually comes into play. So we are using assert.field equals, and then we're giving it the entity type, the entity ID, the name of the field that we want to check, and the expected value for that field. So after all of this, we are supposed to see if the field equals what we want it to equal. And then we clear the store before the next test. Now let's actually run all of this. So to run it, we need to go get our binary from the documentation. Over here, I'm just going to copy the script for macOS. I'm going to paste it here, and that's just going to download the binary for us. Now, in the near future, Matchstick should be added to Graph CLI. So this step wouldn't be needed. You would just do graph test and then the name of your data source, which is my data source in our example. But for now, we need to get the binary. So the binary is already downloaded. It's just a Rust binary file over here. And now how do we run the tests actually? So we're going to do graph build. So build the one important step that I almost missed is in the mapping file, we need to actually export the run tests function defined in the unit test folder. So we are exporting that from test example test. And this is really important because this is how our unit tests get bundled in the WebAssembly file that the Rust binary is going to run, but you don't need to know anything about that to run the test. So you do graph build and matchstick, and then the name of the data source. So the name of the data source is my data source. We're going to run that. It's not working because I didn't specify the return type of return tests, which is void. So now it's going to build all of this. And there we go. We have this little str here, Matchstick igniting tests. Our simple test actually works. And if we were to say Donnie or something that isn't equal to the value that we've set above, the test should fail. Yeah, we see expected field names equal Donnie Draper, but was Don Draper. So we tried to add as much as verbose error messaging as we possibly could, just because if there's something wrong, the subgraph developer should be able to see that immediately running Matchstick. So that's it for our first unit test, actually. And that this is the simplest possible use case for Matchstick, but is also the most used, the one that's going to be used mostly, we think. So we're going to define the next test, which is going to, I want to show you how you can load objects to the store before running the handlers, because that's another use case that might be useful. So let's just check the documentation again. So over here, you can see this one basically. So what this does is it instantiates a entity with an ID. So I'm just going to import that. And now we need to import value. Let me just show you. This one gets added from the generated schema, and value is from GraphTS. So we are creating our entity with an ID, and we're just hard coding its name, and we're saving it to the store. And that's it. And this is useful if you want to load a bunch of entities to the store before you run the handlers, or just you want to see how those entities fit in the store. You can assert their values and all of that. But that's it, really. So that covers the most basic use case for Matchstick. And with that, I'm just going to move to this blog post now to just look at a bit more advanced, well, I shouldn't say advanced, but a bit more verbose functionalities that you can use with Matchstick. So the first one is you can actually mock Ethereum smart contract calls. This is important because oftentimes in the mappings, you would need to instantiate a smart contract object and call a function from it. And you use that return value from the function. But sometimes that function also reverts, and we're going to get to that as well. But if you just want to mock the smart contract call, you would need to create mocked function from Matchstick AS, Assert. Also, we already know that, and we are importing the contract object, which should already be generated for you when running graph build. Then what we do is we create the contract address, and we create a argument, which is just an example string. So this is, I guess, the most important bit, where in order to mock a smart contract function, you do create mocked function, and then you pass in the contract address, because multiple smart contracts can have functions with the same name, right? So we need to know the contract address. Then we provide the function name, and then function signature, because Solidity, as you know, supports method overrides. So we need to know exactly the signature of the function. So then we say dot with args, and then we pass in an array of arguments, because obviously if you call the function with the number 5, it's going to do different things than when you call it with the number 7, right? So you would need to specify exactly which arguments are going to be used when calling the function. Then you do dot returns, and you provide a Ethereum value for the result of the function, which is a string result. So then what you do is contract bind with the address, as you would normally in your mappings. And then for the result, you do contract.try function name with the argument. I'm sure the syntax is familiar if you've used smart contract functions in your mappings. And then we just assert that it's actually equal to result, which it will be because it is mocked here. Another important thing is you can force the mock function to revert to see how your mappings react when a function gets reverted, which is really important because you want to handle those things gracefully and you don't want your data to actually be wrong. So exactly the same thing, you would do create mocked function with contract address, name of the function, function signature, dot with args with an array of arguments, and then dot reverts. And this is going to cause when you try to call this function, it's going to revert like a normal smart contract function if it reverts in your mappings, and you would need to handle that accordingly. Another important thing is interacting with event metadata. So the event object in your mapping file in your subgraph can hold different fields on it, which are its metadata, right? So things like, let me just jump into the demo subgraph real quick because I want to show you what the metadata actually looks like. So if I do this, and let's just jump to random test file metadata. So the event has a log type. It can have an address, a block hash, and all of these other things. So when you wrap your event object, so you would need to import the add metadata function from Matchstick.js. And then when you create an event, you can just call add metadata and provide your event as an argument. And that's going to inject all of these fields to your event object. Then you can read those fields by just basically calling them over here. So event.logtype, for instance, you can change them. So you can say event.address equals to a new value. And then you can use those if you use them in your mappings, you can set hard-coded values for them. Another useful thing is a certain variable equality. So the assert class, which we used before for asserting fields equality. So we did assert field equals. You can also use the assert class to assert variable equality. So you can say assert dot equals, and you pass in two Ethereum values, and it'll tell you if they're equal. This is useful when, for instance, inside of the handler functions, when you check, when you want to be sure that that a field on your entity equals a specific value mid test, right? So inside of the handler somewhere, this is useful as well. And in the future, we're thinking of adding helper methods like assert.address equal. So you don't have to do Ethereum.value from string. You can just pass in two addresses or two strings. Now, in terms of logging is not so different from GraphNode, to be honest. It has some different attributes to it, but if you want to use logging in your unit tests, you would just import the log object from Matchstick.js, and then you can call log.success, log.error, debug, info, and warning. And here's how all of those look like in the test output. So this is a success, this is the error, debug, info, and warning. Another thing to note is when the tests are over, we actually show the execution time of the tests. So this is important if you want to see how much time your mapping logic is taking. So if you have a bunch of for loops and stuff inside, or some very intense logic, your mappings can take a long time. So that means that as a whole, your subgraph will take more time to sync, and that's something you may want to monitor. So here you can see the execution time of the unit tests, which inside of them, they have also all of the handlers that are being run in the tests. So another thing you can do, you can simulate a failure. So you know how in your typical mappings, you can do log.critical. Here you can also do log.critical, and what that will do is stop the execution of the tests and give you this error, because obviously if you have critical errors, you would want everything to stop executing. You wouldn't want to have wrong data. That's pretty much it in terms of the more advanced functionalities of Matchstick. So currently Matchstick is in version 0.1, which is the MVP version. There's a lot of room for improvements. There's a lot of feature requests that we've already gathered. So this is, I think, a good time for me to mention that inside of the Graph Discord, there is a Matchstick early testers channel where you can give all of your feedback, all of your advice for framework. If you want to ask something specific, maybe this would be the best place to do it. But also you can go to our repo inside of issues. So here's basically where we track what needs to be done, all of the feature requests, all of the bugs, all of the things that we want to implement. And you can go ahead here and open up a new issue. Actually, I can see now that there is a new issue that I haven't seen, so I'm going to check that out after this video. But yeah, you can open up issues in our repo as well. I think that's pretty much it. So thanks for sticking around, and feel free to send us a message in the Discord.